Uh, Hello everyone. I was actually using this program called Adams recently. I downloaded it as a student version. You can download it for free. But something I noticed is that I couldn't find any proper online tutorials to actually get started. Like uh, what keys do you have to use, and like what shortcuts you have to use to maybe draw things and maybe put some connections between two links and then give some motions, because to figure that out I kind of took a lot of time, 3 to 4 days. I thought it'd be very helpful for people who are just getting started onto this software to make it if I make a tutorial on this. So I'm going to just explain what I've learned in these few days and what I think is like the basic essential, so that you can understand any other tutorial that's online. Mostly other tutorials online don't explain this basic stuff, how to select objects and how to link objects together, how to merge objects, how to create holes in the objects. So first of all, when you open Adams, this is what you're going to see, a blue area. This is basically the x-axis, this is the y-axis, and now here we have something called bodies, connectors, motions, forces. So I know what these four things to do, and there is another thing called simulations, and I'll explain that too. So basically you normally choose this this is just a normal select pointer. It kind of selects the objects and it's the basic one. So for example, now you want to create a mechanism like a simple mechanism like a 4-bar mechanism. Now you can see here there is a pre-made bar symbol. You can create bars with this. You can create cylinders, spheres, frustrums, torus, and planes, revolutions, and everything. This is a box. So when you're creating a rigid body, you select that. Now here you can see some numbers. If these are like a preset, if you tick all of these, you can actually click on here, and the arm will be formed of the exact dimensions of whatever the number you have given an input here. So instead, okay, if I press it here, you'll have this arm. Now now you can delete that by clicking on part 2 here. Delete. The ground is the part 1 for us. It's kind of like the default. It exists everywhere in this software. So ground is the stationary, this solid that you cannot see, but it exists. Or if I click this and if I untick all of these, now I can actually click on a point and drag, and depending on how much I drag, I can change the size of it. It's not fixed. So for example, we are creating a 4-bar mechanism, so let's just do this. Now I created a bar. So the thing with this is it automatically snaps to these points. I believe they're separated by 1 centimeter, all these points. Now let's create another bar. Now if you go to the end, you can actually see the small circle coming. If you press on that, it'll start from there. Now you create another bar. Now you create another bar from this end till here maybe. Now you create another bar from here to here. Finish this. Now we got 4 bars attached here. I don't think this will actually make some revolutions, but okay, this is how it is. Now you just made the bars. Okay. Now you can actually, there is a globe kind of symbol here. Okay, you can't actually see it with this. Okay, now you can see. If you press on it, the objects change into wireframe. If you press on it again, the objects change into solid. It's like solid to wireframe conversion. So that's something. Now what you want to do is you want to link this bar with this bar, this bar with this bar, this bar with this bar, this bar with this bar with a joint, like a hinge, you can say. So like now we were working the bodies section where we can create bodies. Now we go to the connectors section. Now you can see there is a connector which has a symbol of lock, which means it will fix those two bodies. Those two bodies will act like one single body. There is another. This is a revolute joint or a hinge. This is a translational joint, like one body slides over other or slides into another. This is a rotational joint, like a cylinder rotates into a hollow cylinder. This is a spherical joint, and so like there are many joints. For now we are going to put hinges. So if you want to put join, let's say this body and this body. You want to join these two bodies. So what would you do? You would choose a hinge. You'd click on this and then click on this. Now once you click on these two bodies, now as you move your mouse, you can actually see small circles forming. So you want to create this joint here where these two bodies meet. So you click on that. Now done. There is a joint over there. So those two bodies are hinged at that point. Now you want to create 3 more hinges. You click on this, you click on this, click here. Now again, click on this, click on this, click on this, click here. Now every time you want to create a joint, you need to go there, you need to click on the hinge joint symbol, you need to click on an object, you need to click on another object, and click on the joint. Now you have formed 4 joints. Like these are like hinged. It's like a hinged quadrilateral. Now what you want to do is you want to fix one of the bars to the ground so that it remains stationary, and the rest of them move on it. So to fix it to the ground, you need to use this joint. It's a fixed joint. Click on it, click on the part, click on anywhere else, it's ground. Click here. You can click anywhere, even here or here, but joint is found, so it's fixed. Now all these exist like this. Now you can see that gravity is a default option. It is always on. So now this is the point. Now you want to give motion to this rod. You want that rod to rotate, and now you want to observe the rotation of this rod. So what you do is, now you go to motion. Now you want to give a rotational joint motion. There is also a translational motion. You want to give a rotational joint motion. There are these point motions and general point motions. We'll go to that later. Click on the rotational joint motion, and you have to click on any one of these joints. Like if you press here, it implies that you're going to give a motion to the rod that is not fixed. The joint, the object, the green color object is fixed to the ground, so only this object will be moving. Now once you have given the motion, it means that it's going to rotate in that direction, in the anti-clockwise direction. So now we are done with this. Now let's go to simulation. Click on simulation here. Now you go to this one. Now we have a dialog box here. Now this is the end time and this is the step size. Let's put the step size to 0.1 and let's put the end time to 25. Now we play this. When you play, it keeps rotating and it ends at 25 seconds, I guess. And 0.1 is somehow scales the 25 seconds into something. Like the lesser you keep the step size, the slower your simulation is, the more detailed your simulation is. Okay, every time you restart the simulation, you need to click this to play this. It's like super slow. It's super slow. It's pointless. Let's just go with 0.01. Let's get back and let's play it again. This is what you can see. So this is a basic 4-bar joint. This is just the basic joint. So you can actually create a lot of mechanisms in this way. Fix one of them and this. Now let's go to something else. Now you have a lot of buttons on the top here. Let's see what all these do. This is save. This is redo. This is undo. You probably know what redo and undo is. Undo in the sense, if you did something, if you press undo, you'll go to the back step. This is a normal select button. This is the weave. Like you see, this cube is colored in the front. So if you click that, you'll get the front view. If you click this, you'll get the side view. If you click this, you'll get the top view. If you click this, you'll get the isometric view. And what's that? That is not really that important. Now let's go to this view fit. If you click that, it will fit screen to the object that is in the middle. Now if you click this, now if you actually zoomed out somewhere into some other place, if you want to get back, you just click this front and click this. It will just fit everything in the middle. Now this hand I'm sorry, probably that didn't appear. If you roam somewhere else into the space, if you want to get back to the center of the object, you click this and you click this. You'll get the front view and the centered view of the object. Now this hand symbol, you can drag the screen. Alright. Now with this rotate symbol, you can rotate the whole space. Now you again, if you want to get back to normal, click this, center it, click this, done. So this is the zoom. You click that. If you click on the screen and you drag back, it zooms out. You drag in, it zooms in. You drag out, it zooms out. You drag in, it zooms in. So that's how it works. Now you want to go back to normal, you click this. Just fits the whole screen to normal. This is front view, side view, top view, isometric. Now these are the basics. Like I took a lot of time to figure all these out because I didn't see any tutorial that explains all these. These are essential when you kind of, I guess, when you kind of learn any software, SolidWorks or Photoshop, Illustrator, or any kind of software. Now, once this is done, this is like basically creating a simple mechanism and seeing what it looks like. Alright, so we can actually go to machinery where you can create many things like belts and chains and everything. I didn't actually learn these yet. I'm still working on this. I guess you can actually wait. There are now these are called forces. I'll explain them. You can actually change the gravity here. This is the gravity. You can add forces. Now actually, if you remember the simulation that I just showed you now, you actually saw that this body went through the green part. It passed through the green part somehow, like it didn't act like a solid object. So for that to happen, you need to use this for it to act like a solid object. Create a contact. It's under the tab of forces. It took a lot of time for me to actually make this. So let us actually work on another example to understand what the create contact does. I'm going to delete all of these, select all of these, and click delete. Delete all. It deletes the whole links and everything, motions and everything. So let us simulate a simple. Let us simulate a simple collision between two spheres. Okay, I've chosen the sphere thing. Now we can actually fix the radius here, and if you fix the radius, you can actually click on the screen and it forms a sphere with that as the center of the sphere. So, but I'm not choosing that. I'm going to the origin. I'm just clicking and dragging it out. I formed one sphere. I want another sphere on the top of it so that these both collide. Clicked it and expanded. I just want to make sure these two are of the same size. Now I want to just drag it a little bit into the center. I use the hand tool. Now what do I do is I want to fix the sphere at the bottom to the ground so that it doesn't move. So I go to connectors, lock, I click on the part 2, click on the ground, and I click on that circle that's formed. It's locked. Now remember that there is gravity, so if I actually simulate this now, the upper sphere will fall, but it's passing through the lower sphere. I don't want that to happen. I want it to collide with the sphere and like bounce off it or something. So what I just told you is that forces. You go to forces to create a contact. You go to create a contact. Now you have a dialog box here. Now you have two open boxes. So you have to put the names of the objects in these. So you have to put the names of those two objects so that a contact is formed within it. Now you can see this. It's a normal force. It's an impact. Right? Stiffness, force exponent, damping, penetration depth. I hope that you understand what these actually mean. Stiffness is the surface, the elastic modulus kind of thing. I'm not sure what the force exponent exactly is. Damping is the elastic coefficient. It kind of relates to the elastic coefficient. It's the amount of energy you lose. Maybe it's the ratio of the amount of energy lost or something in that way. You can actually turn on the friction, but I'm not turning that on now. Now, for example, now I have to write the names of these solids. So now I go here. You have part 3 and part 2. Let's just open this up. It's ellipsoid 1. You need to type this name, ellipsoid, not the part 3. So it's ellipsoid 1 and ellipsoid 2. So I'll type the names ellipsoid 1. I'm actually holding the phone in my hand, so I actually can't type with two hands. That's true. Ellipsoid 2. Okay. Now done. There's a contact. You can see that there is a contact. Now let's go to simulation and let's try to simulate it. Let's play. See what just happened. It just fell on it and stopped on it because I guess the damping coefficient was too high. So let's get back. Let's go to here. Let's go to forces, contact 1. If you double click on it, it opens a dialog box. Let's reduce the damping coefficient to something like 2 and let's see if that makes any difference. I'm not sure. I'm actually doing this for first time. Damping thing. Okay, it's still damping super fast. What could the difference be? Penetration depth 4 exponent. Let's try restitution. Let's just try it. Okay, oh C. Okay, now cool. So restitution actually makes it bounce. I guess impact is something like impact is something which actually makes the whole body stop, and restitution is something that makes it bounce. So now let's increase the damping to see if we can slowly bring the height down. Not the restitution. Okay, restitution coefficient. If the restitution coefficient is 0, I guess it's a completely inelastic collision. It's now an elastic collision. So let's go to something like a 0.2, super low value for a restitution coefficient, and let's play the simulation. Okay, that's like super low. Stop it. Increase it a bit. Let's go to 0.8. Let's play. Okay, we have to. Cool. So you get the point. So that's the difference between restitution and impact, I guess, because I've tried that setting for the first time. So this is how this works. I guess this actually helps a lot of people to start off on the software. I've actually started this software 3 days ago. I guess there should be a tutorial like this that explains all the basics of what each button does and how to move objects. Okay, now that this is done, let's go to something more basic. I'm deleting this object. Now we just have this this object. Now I'll explain. Okay, now it's better if you actually choose a square, because if I want to rotate this, you won't be able to see the rotation. Okay, now let's choose this cube. Now it's all actually preset 60 60 60 length, height and depth. So if let's actually reduce the height. Let's try to make it like a plate. Let's make it 10. Always remember, when you're typing these dimension values, you need to type cm after that. If you don't type the units, it kind of assumes its own units and it's not really a good thing. So I've typed in and this is what it's formed. I clicked it there. Now let's rotate and see what exactly is formed. Now you can see it's a cuboid. Okay, let's zoom out a little bit. Now what if I want to move this cuboid such that half of it is on that side and half of it is on this side? So I would like to move it in this direction, in the Z direction. Okay, first let's try to move it in the X and Y directions. First let's see that, because it's simple. Okay, let's zoom out a little bit. Now there is a tool here. You can see that symbol with a yellow color box in the middle and a blue color arrow. You select the object, click on that. Now you have this dialog box open. Now there is a rotation and a translation. Let's first talk about translation. You have something called 10 centimeters. Now you can put any value in that, whichever you want. Now when you press this arrow, it moves by 10 centimeters. When you press this arrow, it moves the minus x direction by 10 centimeters. By 10 centimeters by 10 centimeters. Now if I increase this to some 30 centimeters. Always remember, you need to type in centimeters. If not, it assumes its own units. And if I move it, it moves by 30 centimeters. So you can precisely move how much ever you want. So you put the value and move it. Now let's go to angle. Let's put some 45 degrees, let's say. If you press this, now look at this. There are 4 boxes around it. There are 2 boxes on the sides and there is a small box in the middle. Now what does this small box do? If you want, like when an object rotates, it has to have a center of rotation. So when you press that, you can choose the center of rotation. Now when you press that, you can actually move the object around and you can see. For example, I want to rotate it about its own center. Let's actually, okay, now again you have to go to this tool here. Now click on the center. Now you get this. You can choose the center. Okay, if you click there, it's the exact center of this cube is chosen as the center of rotation. Now, if I press this, it rotates 45 degrees, and this rotation happens based on the direction in which you are looking at it. Now, for example, if you see, it just rotated into some kind of a weird angle, into a weird direction. It did rotate around the center, but it rotated into a weird direction. So why did that happen? Because we were looking at the object in a cross direction. So to undo that, you can either undo it or click the button that's opposite to it. It gets to normal. Now if you want to rotate it in a normal way, maybe like this or into or backside, you need to look at it in that direction. Now for example, I'm looking at it from the front view. Now I rotate it. So what happened? It rotated like this. Let's actually change the view and see. You see, it rotates like this. So now let's go back to the front view and let's undo the rotation. Now what about the top and so you can see that it rotates in this way when you press these buttons. Now what about the top and bottom? So it rotates this way. What about these? It rotates this way. Okay, now that we're clear on rotation, now from this box you can rotate the object in all three directions on all three axes, and you can translate it on X and Y axis. Now what if you want to translate it on Z axis? You don't have an option here. So for that you need to go to edit, move. Now here we have a bit more detail, I guess. Okay, so here you can move it in the Z direction. Now you see you have a translate Z, Y, X. You can either, if you press on this, it goes to 100 or plus 100. If I press on this, it goes to minus 100. So let's keep the value with plus 10. Let's keep it 10 centimeters. Okay, let's try to move it in the minus Z direction. So it's minus 10. So it goes back. Now if I reverse the sign, it goes front. Now if I reverse the sign, it goes back. I can move it how much ever I want. If I want to bring it back, I change the sign and bring it forward. Now I can also move it in the X direction here. I can change the sign, I can move it in minus X direction. So you get it. So for the rotation, I think this tool is more comfortable. This tool. For the translation, that tool is more comfortable. Now if you know SolidWorks, you'll also know these. This is the fillet. Through this you can actually make small holes. Through this you can make extrusions at emboss. Through this you can make an object into a solid shell, hollow shell. For example, let's try this shell part. You have to click on the shell, you have to choose the object, you have to choose the face, and you have to right click. It forms a shell. It's like a box. It's like a little box. It has a base to it. It's like a box. So you get it. So let's go to front view. Okay, so that's about moving the object. Yeah, so that's how it works. So if you actually want to construct an object at a particular position in space, let's say, or actually, since if you want to construct an object randomly, if you choose an object and try to construct it, it always snaps to the closest white colored point. You don't want that to happen. If you want it to be somewhere in the middle, and what you do is, let's delete these. Okay, I'm sorry, I don't exactly remember how that works. I mean, you can actually, I guess it was right click. If you right click, a box appears where you can enter the coordinates, and that is chosen as the starting point of the object. I'll try to tell you if I make another tutorial for that. So yeah, that's the thing. You can actually join two objects as one object using this unite to solids tool. For example, let me just make a simple. Now you see this, and let's create a cylinder. Now you see these two have two different colors. So they are two different objects. Let's rotate it a bit. So it looks something like this. Now if I want to join these two objects, I click this. I click on this object. Click on this object. They become one object. See, you can only see one object here. So that's the point. Yeah, and you can actually make very cool simulations with this. I've tried few and I didn't actually save them, so I can't show you. I tried to create a ball here that rolls on a slope and jumps into a hoop and then falls into a box. It's some kind of simple thing that you can make to have practice. So I guess I'll end this tutorial here. I hope this actually helps a lot of people into starting this, starting learning this software. There are many things that I still need to learn. This is what I've learned in all these 3 days. So yeah, forces you can actually. I hope you can actually understand because it's quite self-explanatory. You can choose one of the kind of forces. You can choose the object. You can choose the surface. You can choose the point. You can put springs between two objects. It's a damper. You can change the properties of springs. There's a circular rotational spring damper. You can change the gravity. A lot of things. So yeah. So thank you guys for watching.